So now we're going to be dealing with solving inequalities using addition or subtraction. And this goes along with lesson chapter 3, lesson 4. So let's talk about what an inequality is. An inequality is not the same as an equation. An inequality is actually something that's similar and has some similar properties, but let's look at this for a second here. If I have here inequalities, I know you guys have worked with these before. 3 is greater than 2 is an inequality. 3 is greater than or equal to 2 is also a true statement. Those are true statements. If I wanted to go ahead and switch it around, I could go ahead and have 2 is less than 3, or 2 is less than or equal to 3. Now we're going to be talking about algebraic inequalities, so that means we're going to have variables. So if I have x is less than or equal to 3, that means I plug in a value for x and see if it's a solution. Is 2 a solution? Yes, 2 is less than 3. Is 5 a solution? No, it's not. But is 0 a solution? Yes, it is. So there's actually frequently going to be an infinite amount of solutions for an inequality. So it's less exact than with an equation. So that's something that sometimes people get confused with. So if you look here, we're going to look at this section here. Replace each blank with a less than, greater than symbol. 2 plus 3 is 5. 5 is greater than 4. 17 is that greater than or less than 23 minus 5. 23 minus 5 is 18, so that's going to be greater than. So it points that way. And negative 18 is greater than negative 19. So this is the example of an inequality that we're going to solve, and the solution of an inequality are all numbers that produce true statements. And it's solved very similarly to an actual equation. I know I keep emphasizing that, but that's really important. If you add something to each side of the inequality, you can do that. If you subtract something from each side of the equality, you can do that. And it's the same inequality. It just looks a little bit different. So it says here, we can graph the solutions on a number line rather than listing all the possible solutions. You're going to do this on the homework. It says here, x is less than or equal to 9. And really important thing here is that symbol there. If you look here, less than or equal to, we use a circle and we color it in, because that indicates the number that the circle is on is a solution. So the solution to this would be all numbers pointing this way. And the way I like to do it, I like to check with what the value of 0 is, if that's a true statement, to make sure my arrow is pointing in the correct way. Because that's how we denote, that's how we make it clear that we have all the solutions, by drawing an arrow like that. And I plug in 0 into the original equation. Is 0 less than or equal to 9? Yes, it is, so I know I'm pointing in the right way. Now, this equation, or inequality, inequality says n plus 7 is greater than 3. So what I'm going to do is I'm going to subtract 7 from both sides, just like I would with an equation. N is greater than negative 4. Very important to understand here that it's greater than, so negative 4 is not a solution. So I use the hollowed out circle. And so n is greater than negative 4, so I go ahead and go this way with my arrow. And then I plug in the value 0 into the original equation. And 0 plus 7 is 7. Is that greater than 3? Yes, it is. So I know I'm pointing in the right direction. That double check will solve you a lot of problems, because a lot of times people mistakenly put the arrows pointing in the wrong direction. So, oh, by the way, my favorite movie that I saw all summer long was Guardians of the Galaxy, and you should know that for the form. So let's move on here. We have the next one, which is 10 is greater than or equal to y plus 3. So I'm going to rewrite that. 10 is greater than or equal to y plus 3. So we're going to solve that by subtracting 3 from both sides. When we do that, we end up with 7 is greater than or equal to y. So now I'm going to go ahead and have my 7. Let me see here. 7 is going to be filled in. Is greater than or equal to y. So it's going to be everything pointing in this direction. And to check that, again, I'm going to plug 0 into the original equation. Is 10 is less than or equal to 0 plus 3? Or is 10 is greater than or equal to 0 plus 3? That's a true statement, so I know my arrow is pointing in the right direction. Let's do this one here. Negative 6 is greater than or is less than or equal to x minus 9. I add 9 to both sides. When we do that, we end up with 3, and that's x. So x is greater than or equal to 3. So I have to go ahead and do the colored in circle, and so x is greater than or equal to 3, so I make it go that way. And now I plug in the value of 0 into this equation. Negative 6 is less than or equal to 0 minus 9. Well, that's not a true statement, but that's good because 0 isn't on my arrow or on my point. So I know that I'm doing it right because 0 is not a solution. I still like to use 0 because it cuts down on the math. So here, x minus 12 is less than or equal to negative 4. Let's set this up. Okay, so I solved the equation, and now I just wrote down, I chose to put the center point being 8. So 8 is greater than or equal to x, so that's going to be a filled in circle. And so since x is less than, it's going to be heading that way. And again, I can plug in 0 into this equation again. 0 minus 12 is less than negative 4, so I know I'm pointing in the right direction. Okay, similar sort of thing here. 6 is greater than y is what the solution is going to be. I added 7 to both sides of that equation. And when I end up with it, I have to have a non-filled in circle because 6 is not a solution. And 6 is greater than, so it's going to be pointing in this direction as well. And then I plug in 0 into the original equation again. I get negative 1 is greater than 0 minus 7, and that's a true statement, so I know I'm pointing in the right direction. So, all good. For this problem up here, the rest of these are all additional examples. We'll do some of them in class, but a traffic reporter announced that traffic will be delayed at least 15 minutes, write an inequality to represent that. So if I were to do that, I'd say time at least, so it's going to be greater than or equal to 15. So that's how you would represent that as an equality if we let t be equal to the time. And we're done.